Hi, Jocelyn.
Hello.
How you doing today?
Doing pretty well. How are you doing?
I'm good. I just tested, make sure you can hear me and see me, okay? Okay, great. And we're waiting for some, so far you the first, so we're waiting for other students to join in, okay? Let's see. Hello, Brianna. Hello, Gabriella.
Hello.
We're waiting for other students to pop on. Hello, Angelina. Gabriella, hi. Gabriella, can you hear me? I'm testing.
Yeah, I can hear you.
Okay, great. Thank you. Hi, Charlene.
Hi, how you doing?
I'm doing good, and you?
Good, good.
Okay, just checking everybody in and saying hello, making sure y'all can hear me. Hi, Mackenzie. Hi, Mackenzie.
Hey,
Okay, just checking. See, huh? Uh-oh, that's not good. You pay attention now. Your safety's first. Okay. Hi, Jay.
Hi.
Hi, Jacqueline. Hi, Gina. I'm just testing to make sure you ladies can hear me. So a hi or a thumbs up would be greatly appreciated. Okay. Okay, I'm just gonna give it a couple more minutes and then I'm gonna get started. I have Jay, Gina, Mackenzie, Angelina, Jocelyn, Brianna, Gabriella. See, who did I miss? Okay. So today we're still going over chapter 5. I wanted to just go over some question and answers and the key terms. Okay. You'd be surprised that if you do your key terms and study your chapter, you do so much better on your test. And of course, your smart notes, it's all designed to work together. So we'll just go over some of these key terms together. And if you have any questions, please ask at any time. Okay. One second. Okay. So I might not necessarily go in order as your key terms that's on the back of your homework assignment. But if we don't cover one, you can always, and you couldn't find it when you looked it up, you can always share it, okay? So acid. Acid is more positive hydrogen ions than negative hydroxide ions. That's the definition of acid. More positive more positive hydrogen ions than negative hydroxide ions. Okay, once again, since I was tongue-tied, more positive hydrogen ions than negative hydroxide ions. Okay, any questions about that? Acid? Okay. Acid balanced with the same range as skin and hair. Okay, it's 4.5 to 5.5 on the pH scale. Acid waves. The main ingredient is glycerol monothioglycolate. That's the main ingredient. And its speed is sacrificed for a more controlled curl. Heat may be used. So this is in your acid waves. Okay, that's the one that's opposite of the cold wave. The heat is involved. Okay, acid balanced shampoo. Made to have the same pH as the skin and hair. Will not strip the hair. So that's acid balanced shampoo. Alkali. Short for alkaline, alkali, that's how it's pronounced. It's a chemical compound that neutralizes with acids and turns litmus blue. That's the sheets. Remember the pH strips? Because it's so high, just like I showed you yesterday, when I dipped it in the yellow strips and I dipped bleach and ammonia in there and it came up blue. That just shows you that's high on that pH scale. That's in the 11.5 to 14 range. Okay. Typically a caustic or corrosive substance of this kind, as in lime or soda. Okay, they talk about Coca-Cola and Pepsi all the time. They say if you put it on a car, it takes the paint off. I never tried to take paint off my car personally, but the scientists have tested it, and that's what they say will happen. That's how strong it is. Okay. All-purpose shampoo is low in alkaline, low surface active agents. It's mild and does not strip the color. Can be antifungal. All-purpose shampoo. Okay. Aminos is an organic compound derived from ammonia by replacement of one or more hydrogen atoms by organic group. Do you ladies do the key terms at all? Oh, great. Okay. Amino acid. Compounds of COHNS, COHNS. What does that stand for? carbon, oxygen, hydrogen, nitrogen, and sulfur. Okay. They have 22 common amino acids joined together in a chain to make a protein. Okay, ammonia is a colorless gas with a characteristic smell. It dissolves in water to give a strong alkaline solution. Okay, a solution of ammonia used as a cleaning fluid. Some people will get a straight ammonia out the bottle and they use it to clean the bathroom and the kitchen areas. And you can also put it in when you fry fish. This is just an old thing that we do. When you fry fish, you can put a little bit in a bowl and it kind of just absorbs all that fish smell that's in your house. Just for FYI, I just want to throw that out there. Okay, a compound is a thing that is composed of two or more elements, a mixture. Compound, a thing that is composed of two or more elements, a mixture. Dimethicone is the ingredient to know for smooth skin and shiny hair. So that's an ingredient that they put in products when you hear the word dimethicone. Is used for smooth and shiny hair. Okay. Welcome, Jennifer.
Thank you. How are you today?
I'm doing fine. How are you?
Working. Let 'em hear.
Oh, yeah.
Hello.
Yep. That's, oh, hi. Hi, little one. How you doing? Okay, who else does I see? Okay. All right, so we're just going over the key terms, those who just joined us. Okay. Fatty alcohols are usually high molecular, okay? They are usually high molecular weight. The straight chain primary is alcohols, but can range from as few as 4 to 6 carbons, okay, to as many as 22 to 26 derived from fats and oils. That's the definition for fatty alcohols. Hydrometer is an instrument for measuring the density of liquids. We talked about that. This can be divided into two classes: liquids heavier than water and liquids lighter than water. And since we're talking about ways to measure the pH, there was a question yesterday from Jennifer and wanted to know if there's any other color strips out there on the market to do the pH test. Remember, we talked about that. And yes, I told you I was gonna come back with an answer. So I came back with universal indicator paper. Okay, when you look at the paper, the bottom is white, then they have an orange bar, a gray, and then a yellow. Okay, so the less acidic solutions we know are on the left side of the scale, right? Orange and yellow. White will be the neutral solutions, and gray and green will be, okay? So basic alkaline solutions are the blue and purple. Remember yesterday when I did the ammonia and the bleach, how it turned the dark purple, looked almost black? So we know that's on the alkaline side. So these yellow strips that I did that were on the low side, on the acidic side, they turn kind of orange and some stayed yellow. So with this strip, it will be white at the bottom, the part that you hold, and then it's orange, gray, and yellow. So if it falls into the orange and yellow, it's acidic, and it falls into the blue and the purple, it's alkaline, okay? Why are there 2 or more colors on the strips? More accurate readings. One of the colors goes from neutral to alkaline, and the others go from neutral to acidic. So in essence, going different directions on the pH scale. Okay, so it's up to the person which one they want to use. Okay, because sometimes some people might have a tendency to not see the color for whatever reason. You know, everybody's eyes is different. So it is good to have a backup. If that doesn't work, then you could get the ones with the yellow, gray, orange, and white on it. Okay, I hope that answered the question without getting you more confused. All right, good. I tell you, if I don't know, I'm gonna find out. I like questions. That keeps my brain going too. So we talked about ammonia. Nope, I talked about amino acids. Ammonia is a colorless gas with a characteristic smell. It dissolves in water, and everybody who at least opened ammonia one time in their life, you know it's very strong. You don't ever want to put your nose directly on an open bottle of ammonia. And when you smell it, you'll know exactly what that smell is. You'll never forget it. Okay, it dissolves in water to give a strong alkaline solution. A solution of ammonia is used as a cleaning fluid. And when you see it in the household, most of the old school parents, they're going to use it to clean their bathroom and their kitchen. Of course, they're going to dilute it in water now. It's not going to be straight out the bottle because I don't think you'd be able to staying in the same room with that smell. It's pretty strong. Okay. Compound is a thing that is composed of two or more elements, a mixture. A compound is a mixture, and it has two or more elements in the mixture. Okay, I feel like I'm reading this again. Did I? Okay, on my own notes. Dimethicone. Dimethicone is the ingredient to know for smooth skin and shiny hair. Okay, dimethicone is the ingredient to know for smooth skin and shiny hair. Now remember, that's the ingredient that they put in to mix in certain conditioners and shampoos to give it, or skin products to make it smooth and shiny. Okay, I did read all of that already. I can't even mix it up on my own. Logarithmic. Logarithmic, a measure of pH as acidity and alkalinity. Okay, it's another form to measure the pH. Okay, miscible, miscible, miscible is two liquids that appear to mix completely together, are said to be miscible. Example, equal amount of water and ethanol, mixed it with any amount of water and you will always end up with clear, colorless liquid. Okay, so what is immiscible? Because that's on your key terms too. That's when two solutions do not mix together well. Okay, like vinegar and oil. When added together, like cold cream. Cold cream is an example of an oil and water emulsion of two immiscible liquids together. Cold cream. So miscible is two liquids that can mix together, and immiscible is two liquids that cannot mix well together. Shelf life is defined as the time under defined storage conditions during which food remains safe, retains desired sensory, chemicals, physical, and biological characteristics, as well as complies with any label declaration. So we use that with our hair products, our color. Everything has a shelf life. Everything has an expiration date. Okay. So just be aware of that. Don't get products and then stays on your shelf for 2 years and then you decide to use it on a client. So be aware of that, okay? Gases. And we can't label all of them because every manufacturer is different. That's why you have to get familiar with the manufacturer, read all product labels, okay? Gases. A substance of matter in a state in which it will expand freely to fill up the whole container, having no fixed shape, unlike a solid, and no fixed volume, unlike a liquid. That is the definition of gases. Emulsions, emulsions, is a mixture of two liquids that would not normally mix. Like immiscible. Emulsions contain tiny particles of one liquid suspended with another. Cream lighteners are chemical compounds that lighten hair by dispersing and dissolving and decolorizing the natural hair pigment. Keratin, a fibrous protein forming the main structural component of hair, nails, horns, feathers, and hoofs. Okay, they just showing you different animals that they have keratin as well. Keratin are rich in sulfur and contain amino acids. Okay, so on my board, I don't know if you can see it or not. Okay. Maybe I'll put it in front of me. There we go. On my board, I drew the chemical structure of hair. First, we have the atom. 2, we have the amino acid. Okay. 3 and 4, we have the polypeptide chain. 5 is the side bonds. And 6 is the hair. So all of these together equals hair. So you first starts with an atom, and then the amino acid, and then the polypeptide chain, then your side bonds equals hair. We'll get back to some more key terms. I want to go over the role of water. Okay, I know we talked about it, but I want to get more in depth. Water is usually the first ingredient listed on most shampoos, which indicates it is the primary ingredient. Okay, just like when you making better choices with food products, they tell you the first ingredient is the most ingredient. So if you pick up some bread and it says wheat, that's what the most ingredient that's going to be in that bread is wheat. If you pick it up and it says flour or bleach flour, oh, he trying to tease me with your lunch.
No, you said just like when you make better food choices. I'm checking on my diet as we speak, and he just didn't point it out.
Yeah. So what's the first thing you do when you're on a special diet or trying to eat healthy? You're going to look at that first ingredient to make sure it's not sugar, right? Anything that rhymes with oats, fructose, glucose. Okay, all of that is sugar. So it's the same thing with hair. You want to make sure that you're not picking up a shampoo. I'm giving you a perfect example. A client came in with her prescription shampoo. She had a lot of flakes and things going on her scalp. Well, I kept wondering why after we used it on a couple of treatments, you know, she comes every 2 weeks, her hair kept getting dry and dry. You as the professional, you could tell. She first started, her hair wasn't dry. Now, why all of a sudden her hair is getting dry? So now we got to go through the process of elimination, which means, what did we do and put on her hair that we haven't done before? That's causing this change. Okay, so we had to go through the process of an elimination. So I asked her, let me see your bottle of shampoo again. Long story short, I read the ingredients in the shampoo, and the first thing that came up in the under the ingredient was sodium hydroxide. What is sodium hydroxide? It's a base ingredient lye that they put into relaxers. So every time I'm shampooing her hair, I'm giving her a relaxer touch up, basically. And that's why her hair was drying out. So sometimes even if the doctor might prescribe a hair product, that doesn't necessarily mean that that's the best thing for that client. So long story short, I told her to go back and talk to her doctor. He prescribed something different that was less harsh on her hair. It's up to you to make sure that you reading these ingredients and know what you're putting on these clients' head, because they didn't go to school for cosmetology, you did, okay? So that's why it's important to know these key terms, these definitions for every chapter, okay? So back to water. This is usually pure or deionized water. Remember, water is electrically charged, neutral on the pH scale, and earns the title of universal solvent. So water plays an important part in the success of your shampoo. Water can be classified as either hard or soft, depending on the amount and kinds of minerals present. Hard water or well water contains certain salts of calcium, magnesium, and other metals that prevent the shampoo from lathering. It can be softened by a chemical process. Soft water contains very small amounts of minerals and is preferred for shampooing as it lathers more freely. Water purification. Filtration and sedimentation and filtration are two methods used in the purification of water. During sedimentation, undesirable substances such as clay, sand, etc., sink to the bottom, and then during filtration, pass through a porous substance. Chlorine is added to kill bacteria and complete the purification process. Water boiled at temperature of 212 degrees Fahrenheit or 100 degrees Celsius will also destroy most microbiotic life. Okay. And if you ever notice, like when there's a flood and people they have a water shortage, like they did in Texas, a lot of people had to boil their water. Okay, because once the town floods like that, all these germs and stuff will get into it. So you have to boil your water. That's what we used to do back in the day before there was spring water in bottles. All these fancy Crystal Geyser and all these names of all these different kind of waters and things that they put in water for your electrolytes and all that. It didn't exist back in the day. So if you wanted to make sure your water was sterile, you boil it first, let it cool, and then you pour it in containers and then put it in your refrigerator to cool. Okay. So yesterday we went over the types of shampoos, and now I want to talk about how shampoos work. Even though the hair fiber beyond the scalp is dead, biologically inactive, once the hair grows outside of the scalp, it is dead. And this is why we use certain shampoos and conditioners to keep the hair that's already grown outside of our head strong and healthy as possible until the new hair comes in, okay? And the healthy hair is growing out. A mixture of secretions from the sebaceous glands and perspiration from the sweat glands help maintain the hair and scalp at its natural pH, which is what? We talked about it for 4 days. What's the natural pH for hair?
In between 4.5.
Yep, between 4.5 and 5.5, allowing a shiny, alive appearance. This scalp secretion can be spread by simply running the fingers through the hair or by brushing or combing. Failure to remove these scalp secretions on a regular basis will allow a buildup of oily film. The oily film is an emulsion, a combination of oil, sweat. Hi, Amanda. It's a combination. Hi. It's a combination of oil and sweat buildup. Failure to remove these scalp secretions on a regular basis will allow a buildup of oily film. The oily film is an emulsion, a combination of oil, sweat, dead epidural cells, and dirt particles. Most shampoo is water-based and contains an ingredient known as a surfactant or a cleansing agent. We're talking about shampoos. Surfactants are also called surface active agents and are used to remove oil from the hair. A surfactant is necessary because water alone cannot attack and dissolve oil. For example, if you just wet the remains of a greasy dinner plate of spaghetti, the water will simply bead up. Once you add soap, the grease breaks up and is easily washed away. It is necessary to add detergent, soaps, or other surface active agents, surfactants, to do the job. The molecule of the surface active agent is 2-part molecule. It has a water-loving part, hydrophilic, and an oil-loving part, lipophilic. During a shampoo, the water-loving part is attracted to water, while the oil-loving part is attracted to oil on the hair. The resulting push and pull action causes the oil to roll up into droplets, which are then lifted into the water and washed away. By removing the oil from the hair shaft and scalp, the water can wet the hair and scalp, and the debris can be washed away. Some shampoos contain both surfactant and conditioner. Together, they not only cleanse the hair, but help condition it as well. These conditioners can contain many ingredients, including hydrolyzed protein derivatives. These derivatives strengthen damaged areas of the hair by depositing protein fragments along the hair shaft. Okay. So does anybody have any questions about anything in this chapter before I keep going on? Nope. Okay. So let's go over this again. Remember, this is a review. This is your last day for review. Next week is your test. What is matter? We're gonna have question and answers at the end. What is matter? Anybody want to volunteer? Anything that occupies space. Matter is everywhere. Okay. What kind of matter is this whiteboard right here?
Solid.
Yep, very good. That is a solid one. Water is matter. Nails, hair, and skin are matters. But what kind of matter is water?
Liquid.
Liquid, very good. And what kind of matter is gas? Oh, I said it. What kind of matter is oxygen or the air we breathe?
Want this one? Gas.
Yes. Don't you hate that? You asked the question. I mean, you asked the answer. Okay. So yes, even oxygen is matter. All of these things occupy physical space. Chemistry is the scientific study of matter and the physical and chemical change of matter. Okay. So chemists and scientists who study matter, its properties and changes. Chemists study properties or characteristics such as color, odor, weight, density, which is affiliated with weight. Hardness or softness that define its substance, such as water. Chemists teach that matter exists in 3 basic forms. Okay, and we went over that: solid, liquid, and gases. So for example, hair is a solid because it has a definite weight. And you see how it all correlates. I am so glad you're having a good time, Jennifer. You need to share that.
I'm sorry, my husband and my daughter are fighting. He needs to get in the bathroom like right now. He said, and she's in there and she's done. It's just
Still gotta go.
oh, never mind, she's not done. But they're fighting over the one bathroom we have. I'm sorry.
Oh my goodness. Oh my goodness.
It does have to do with matter, though. There was definitely gas.
Well, that definitely has to do with matter. My goodness. Okay, so for an example, the hair is solid because it has definite weight, volume, and shape. Conditioners, perms, solutions, and most shampoos are liquids. They have weight and volume, but no definite shape. In fact, as you have observed many times, liquids take the shape of a solid container into which they are poured. Did you ever see that test where they have a short glass and a tall glass? They could be the same size, okay, but in the same ounces. But people will always gravitate towards the large one because they think they get more. Okay, well, anyway, that's something separate. But anyway, you look at it, when you pour that liquid in there, it's going to take on the shape of that glass, whether it's a round glass, a tall glass, a short glass. Okay. All right. Oxygen is a colorless, odorless gas. It has weight, even though it may not seem to, but no definite volume or shape. Okay, what do they mean by weight? They have to measure it because there's people that literally in the hospital on oxygen tanks, people walk around with the oxygen tank. They have to know how much they need, weigh it in that container before they can distribute it to that patient. Okay, so even though we can't see it, it is there and it does have weight to it. So I just wanted to give that as an example. I hope it's helpful. So matter can be changed from one of these forms to another in 2 ways, physical and chemical. Yes, we talked about this before, but you see, the more you talk about it, the more you review it, the more it's going to start sticking in here and registering, and then you'll be able to project it, right? Physical and chemical. What is the physical? A change in the physical characteristics of a substance without creating a new substance. Chemical change, a change in a substance that creates a new substance with chemical characteristics different from those of the original substance. So I'm gonna give 2 examples. An example of the physical in matter would be water freezes and becomes ice. It is still water, but now it's a solid instead of a liquid. But when it melts, it'll be back to a liquid. It's the same substance, okay, but it was just a physical change. Now, an example of a chemical change occurs is when hydrogen combines with oxygen to form a new substance of water. Some matter is living and some is not. It is the presence of the element carbon that distinguishes living matter from non-living matter. Chemistry has a special division for each of the matter. So you have organic chemistry. It deals with all matter that is now living or was alive at one time. with carbon present, such as plants and animals. Okay, so even if you had a living plant, it was alive, it was green, it had flowers, and then it died, it was a matter at one time, okay, dead or alive. Okay, inorganic chemistry studies all matter that is not alive, has never been alive, and does not contain carbon, such as rocks, waters, and minerals. Okay, there are scientists that studies rocks, water, and minerals. They could tell how long this rock has been on Earth just by examining it. Okay, and we always have to test the water, especially in our oceans, right? With all this global warming and everything that's going on. So you got scientists that just concentrate on water. Okay, elements. All matter, whether solid, liquid, or gas, whether living or non-living, is made up of elements. Elements are basic substances that cannot be broken down into similar substances. As of this printing of your pivot point book, there are 118 known elements. You see, they say known elements. If the scientists still be in there studying and observing and watching and finding, they might find more. That's why they say as of this printing today, there are 118 known elements. Those above the 92 element are synthetic and do not occur naturally. 5 of these elements, because they form the basic of hair, nails, and skin, are important for the cosmetologist to know. I'm going to read that again. 5 of these elements out of 118, because they form the basics of hair, nails, and skin, are important for the cosmetologist to know. These elements are coins. Okay, remember that coins, and then you remember the technical words, such as C is for carbon, O is oxygen, H is hydrogen, N is nitrogen, and S is sulfur. So to abbreviate that, it's coins. Hair is comprised of 2 solids, carbon and sulfur, and these gases, hydrogen, nitrogen, and oxygen. So in your book, it has a chart, and it says on the left-hand column, it shows each element's atomic number. You'll read more about this number in the next few pages of your book. Even more important to you and your work are the letters after each element's name. These letters, called symbols, are a kind of scientific shorthand, like a nickname, that makes it easier for you to identify the elements. You will see these symbols used throughout this book, in other professional literature, and on some product labels. Oxygen is the most abundant element in the Earth's crust, and the second most abundant element in the Earth's atmosphere. To remember the elements found in hair, use the acronym COINS. And we talked about it. It stands for carbon, oxygen, hydrogen, nitrogen, and sulfur. Okay, so let me write that on the board. See if you can see me from here. So you have your atomic number. You have that on that side, and then you have the list of elements in the middle. And then you have your category. Okay, so they saying one, the element is hydrogen. Okay, and the category is gas. Can everybody see my board? Up, lift it up.
Yeah, you're gonna have to go up a little bit.
Oh God, I don't know how that's going to be. How about if I move it over? That better? Nobody's saying nothing. Two is helium. When you think of helium, what do you think about? I know the first thing I think about. What do you think about with helium?
Balloons.
Yes, exactly. Oh, I left one part out. I left the symbols out. So when you see hydrogen, you're going to see a H. Helium will be a HE. And the category it falls under is gas. So helium is gas. Wait, I got an idea. Is that a little better? Okay, nobody's saying that. Lithium will fall under the atomic number 3. And the syllable is Li. And the category is solid. It's a solid matter. 6 is carbon. And the abbreviation for that, we know is C because it's part of the Cohen's. Okay. And the category is solid. Eight is oxygen. What's the syllable for oxygen? Oh. And it is a gas. 13 is aluminum. What is the syllable for aluminum? Al. What category is it in? It's a solid. Then we have 16, which is sulfur. The syllable for that is S. And you have this in your book. If you can't see my board, that will apologize for that. It's a solid. And then the last one is 80. And it's mercury. And the syllable is Hg. And that's a liquid. Okay, so you have atomic in one row, elements in the other, symbol and category. So on one is hydrogen and the syllable is H and it's a gas. 2 is helium, He is a gas. 3 is lithium, the syllable is Li and it's a solid. 6 is carbon, the syllable is a C and that's a solid. 8 is oxygen, O, gas. 13 is aluminum, Al is the symbol and it's a solid. 16 is sulfur, the syllable is S and it's a solid. And 80 is mercury, Hg and it's a liquid. Okay, and what's the main one that we'll be using? COHNS, carbon, oxygen, hydrogen, nitrogen, and sulfur. Okay. Atoms. Make sure I don't leave nobody in the wait room today. Atoms are the smallest complete unit of an element. What are atoms? The smallest complete unit of an element. Each element consists of a certain kind of atom, different from the atoms of any other element. Atoms have 3 main parts: protons, protons, neutrons, neutrons, and electrons, electrons. Protons and neutrons are packed together tightly to form a dense core or nucleus at the center of the atom. The nucleus is right in the middle of the atom. That's like the brain of the atom. Electrons move about the nucleus on orbiting paths or shells at nearly the speed of light. Now that's fast, the speed of light. Protons have a positive electrical charge. Okay, P for protons, positive electrical charge. That's the kind of way I would study. P, protons, positive electric charge. And identify the atom as, for example, a hydrogen atom or an oxygen atom. Neutrons have no electrical charge. Neutrons, no electrical charge. They are neutral. That's the other way to remember. Neutrons, neutral. Hence their name, neutron. The neutron determines the weight of the atom. Okay, they are neutral, hence their name. They got their name from neutral, neutrons. Electrons have a negative electrical charge. Electrons have a negative electrical charge. Under certain circumstances, they make it possible for atoms to unite with other atoms to form bonds. They make it impossible. Okay. The chemical behavior of an atom depends mostly on the number of electrons in its outermost orbiting path or shell. Some atoms, by their very structure, are not missing any electrons in their outer shell. These atoms are considered stable and are electrically neutral. If the outer shell of an atom is missing electrons, however, the atom is considered unstable or reactive. Unstable atoms seek other atoms, which with they can share electrons to complete their outer shell. When they combine, they make more complex units known as molecules. Molecules. When unstable atoms combine chemically by sharing electrons, they form molecules. A molecule is two or more atoms joined together by a chemical bond. If the atoms that combine are different, for example, an atom of hydrogen and an atom of oxygen, the resulting molecule is a compound. So once again, if the atoms that combine are different, for an example, you have an atom of hydrogen and you have an atom of oxygen, the resulting molecule is a compound when they are two opposite. Different atoms joined together as molecules become the smallest parts of the compound. Chemical bonds. You are now familiar with the diagrams of atoms of the 5 elements of hair, right? Everybody knows it, should know by heart now. What is it? Cohen's. Carbon, oxygen, hydrogen, nitrogen, and sulfur. These atoms combine chemically to create. Hi, Vanessa. Hi, Vanessa. I don't know if people mute as soon as they come on. When you mute, you can still hear me. I'm just testing. I don't know. Oh, you can? Okay. So they just don't want to say hi to their teacher. Is that what's going on? Hi. Oh, the husband gonna say hi. That's nice. Hi, Vanessa. No response. Okay. What time is it? Hi. Okay, so now you are familiar with the diagrams of the atoms of the 5 elements of hair: the carbon, oxygen, hydrogen, nitrogen, and sulfur. These atoms combine chemically to create compounds that eventually create the protein of hair. To see how they join to form hair, you will need to learn a little about chemical bonds, starting with the amino acids. So I will refer you to your book so they have the diagram for you. Okay. The amino acids are kind of cleaned together. Okay, like little circles and balls. But remember, you can only see those under a microscope. Okay. So amino acids. Are compounds consisting of carbon, oxygen, hydrogen, and nitrogen, excuse me. There are 22 amino acids. These amino acids join together in chains to become proteins, which provide the chemicals that body needs for the growth and repairing of tissues. Although amino acids create all proteins, each protein is different because of the way it is put together. Hair is a form of protein called keratin. Keratin in hair contains 19 of the 22 common amino acids. In fact, hair is made of 97% keratin and 3% trace minerals. The chain or the order in which the amino acid links together makes each type of protein one of a kind. Also, the number of amino acids in the chain is important. For example, the 19 amino acids found in hair must all be present or the structure won't be hair. Hi, Jacqueline. Peptide bonds. The amino acids that create protein are linked together end to end by a protein bond. Okay, so the amino acids that create the protein are linked together end to end by a peptide bond, also known as the end bond. The peptide bond is the backbone of all protein. Okay, once again, the peptide bond is the backbone of all protein molecules. When two amino acids are positioned end to end, the acid end of the one amino acid attaches to the amino end of another amino acid. The peptide bond forms when these two ends join. The polypeptide bond, poly means many, poly means many. So the many polypeptide bonds connects thousands of amino acids lengthwise to form a chain. In other words, here is the linking together of protein groups. You, as a stylist, will be altering these links. You need to know how your techniques and tools will affect your client's hair. It's very important not to disturb the peptide bonds. For instance, if you put a sodium hydroxide relaxer under a hair dryer, the combination of the alkaline chemicals and the heat could break these critical peptide bonds and destroy the protein structure. If they are broken, the protein chains separate into small fragments or revert to groups of amino acids that no longer have the characteristics of hair. If you was to ever put a sodium hydroxide relaxer under a dryer, which is strongly not recommended, that client hair will be breaking off. It's too much heat on that sodium hydroxide relaxer. And remember, that's the chemical where it's going to turn your curly or naturally wavy hair texture to straight. So if it could change curly or naturally wavy hair texture to straight, just imagine how strong it is. Not only is it strong on a pH scale of 11.5 to 14, that's the highest you can go. That heat will destroy it. Okay, so just keep that in mind. Okay. So under a microscope, it's saying that if you put a sodium hydroxide relaxer client underneath the dryer, the combination of the alkaline chemicals and the heat could break these critical peptide bonds and destroy the protein structure. Side bonds. When amino acids combine to form the keratin protein of hair, they take on a spiraling configuration. When these long spiraling protein chains are placed next to each other, they can be linked together by 4 side bonds. The 4 bonds holding protein chains together behave differently, and they each serve as a different purpose in building hair. The 4 side bonds created are 1, the hydrogen bond, 2, the salt bond, 3, the disulfide bond, and 4, van der Waals forces. When giving chemical services, you are affecting all these bonds. Okay, let me repeat that. When you, the stylist, are giving chemical services, you are affecting all of these bonds. In order to minimize damage to the hair, it is important to understand how the 4 side bonds work. Okay, so the first bond, the hydrogen bond, HYDROGEN, which works on the principle that unlike charges attract. Hydrogen bonding takes place when the hydrogen atom in one molecule is attracted to an atom of another molecule that has many negative electrons. Hair has many hydrogen bonds, which are individually very weak and can easily be broken by heat or water. Although the attraction in these hydrogen bonds is weak, there are so many of them in the protein of hair that they tend to organize the protein chains and give hair its shape. About 35% of the hair strength is due to the millions of hydrogen bonds in its structure. A second type of bond between protein chains is the salt bond. This bond is a result of the attraction of unlike charges. The negative charge in one amino acid grouping attracts the positive charge in another amino acid. Hi, Jamila. I hope I said your name right. How you doing?
No,
Did I say right?
no.
Okay, well, help me. Say it.
Jamila.
Jamila. And I
Yeah.
said, okay, I emphasized the A. I apologize.
It's okay.
Y'all got all these fancy names. It takes me a minute. I get it.
It's okay.
Okay. So we're in the middle of talking about the different bonds. Right now I'm on the salt bond.
Okay.
So the first bond, side bonds, that's the general characteristic, is the side bonds. Now we're breaking it down into the 4 side bonds. The first one was hydrogen, and now I'm talking about the salt bond. That's number 2. So the second type of bond between protein chains is the salt bond. This bond is also a result of the attraction of unlike charges. The negative charge in one amino acid grouping attracts the positive charge in another amino acid grouping. Salt bonds also help to organize the protein chains. So they help to organize the protein chains. They account for another 35% of the hair's resistance to change. And like hydrogen bonds, are not particularly strong. Since both hydrogen and salt bonds can be weakened by water, hair can be shampooed, set on rollers, and dried by heat into a new shape. When hair is saturated with water, the hydrogen and salt bonds are weakened, leaving the hair more pliable. Then, by wrapping it around a roller under tension and drying it, the hair takes on a new shape because new hydrogen and salt bonds are formed between the protein chains. However, this set is only temporarily because exposure to water will break the new bonds. Just like with a roller set, as soon as you wet it, they come back for another set, it's going to break the bonds, okay? Even the humidity in the air can break the new bonds and restore the original ones. So for instance, if a client doesn't have any kind of chemical like a sodium hydroxide in their hair to straighten their hair, you know, they wearing it natural like a press and curl or just wearing their natural curls. And they go to a jacuzzi or in a sauna, or they go to on vacation to a warmer climate with a lot of humidity, like Florida, Miami, and the East Coast, I'm talking, we get hot, we have dry heat out here. But if you ever go to the East Coast or the South, that's a different kind of heat. Okay, it's humid. It would change the structure of your hair, like the book is saying, without putting any water on it. You are sweating before you get out the shower. You hoping that it'll rain so it can cool off the city, basically. Using rollers or a blow dryer and curling iron to create a thermal style is referred to as a physical change, since it is only the physical characteristics of the hair that's changed. Okay, everybody gets that, right? It's physical. It's not chemical. Chemical will be the sodium hydroxides and ammonium thioglycolate. That's the chemical change. The sulfur-containing side bond, the disulfide bond, is the most important to your work as a stylist. When the sulfur type side chains join with other sulfur side chains, they form the disulfide bond. Let me repeat that. The sulfur-containing side bond, the disulfide bond, is the most important to your work as a cosmetologist. When these sulfur type side chains join with other sulfur type side chains, they form the disulfide bond. This bond is a chemical bond that forms between protein structures. A lot of your chemical services, particularly perming and relaxing, directly affect the disulfide bond by either breaking the disulfide bond or reforming it into the new shape. This process is a chemical change and creates lasting results. Okay, those are the changes that the client will have to grow out of. Okay, they either grow out of it, get to a certain point, cut it all out, start all over. But basically, you have to grow out of that. Unlike the physical change, all you have to do is put some more water on it or the humidity, and it's going to change. It's going to revert back to its natural state. Does everybody understand that? If you kind of just imagine the client and you walking through the steps of physical and chemical change, then you will kind of remember how these bonds work. Okay, try to correlate it with you actually doing a client. Okay. The side bond, known as van der Waals forces, is based on the theory that atomic groups prefer an environment with other groups that have structures similar to theirs. This type of bonding is not important for your work as a stylist, other than to know that it exists and plays a role in bonding protein chains. So they're letting you know that this van der Waals forces is important. Okay, but not important for your work as a stylist. Okay, we're gonna take a 10-minute break and I'm gonna come back to review chapter 5. Okay, 10 minutes, so we'll be back 3:23. You gotta get it off the Disney Plus channel, it's not on your regular, and you gotta pay for it. Hello?
Charlene. I see you this time.
Okay, welcome back. Okay. So I'm going to just briefly go over the pH scale. We covered that for the last 2 weeks, but I want to go over this again. pH scale stands for potential hydrogen. Is a unit of measurement that indicates whether a substance is acidic, neutral, or alkaline. Alkaline is sometimes called base, B-A-S-E. Just as degrees measures temperatures and inches measures distance, pH number measures the amount of acid, alkali in a water-based solution. As a professional cosmetologist, you need to understand pH and its effects on the hair, skin, and scalp. This means knowing what products have high or low pH and why. Only solutions containing water and or which dissolves in water can have an acidic or alkaline nature. Was there a question? Thought I heard something. No. Okay. A solution is acidic or alkaline depending on the number of negative hydroxide ions or positive hydrogen ions it contains. An ion is an atom that has gained or lost electrons. If a solution has more positive hydrogen ions than negative hydroxide ions, it is acidic. If it has more negative hydroxide ions, it is an alkaline. When a solution has an equal number of hydrogen and hydroxide ions, it is neutral. So we know that the pH measurement scale ranges from 0 to 14, with number 7 being neutral. Numbers less than 7 indicate acid, while numbers greater than 7 indicate alkaline. The scale is logarithmic. Jennifer, can you silence your, I can hear all your background. I think that's you, I'm not sure.
I was muted.
Oh. Okay, that sounds better. Thank you. So the pH measurement scale ranges from 0 to 14, with the number 7 as neutral. Numbers less than 7 indicate acid, and the numbers greater than 7 indicate alkaline. The scale is logarithmic, which means each step or number increases by multiples of 10. So a pH that is 6 is 10 times more acidic than the neutral 7. However, 6 is 10 times less acidic than 5, which falls in the range of the average pH of hair, skin, and scalp. So when you are using products that are pH 6 or only one number away from the average pH of hair, it is actually 10 times less acidic. That is a big difference. For example, have you ever peeled an orange, and as the juice from the orange came in contact with your skin, you felt a slight tingle? That pH of the orange is approximately 2, which is 3 steps away from the pH of your skin, 4.5 to 5.5. As the top of the scale is 14, which is 10 million times more alkaline than 7. 10 million more times. As you can see, a very slight variation in pH will greatly affect the acidity of any salon product. Okay, so to give you an example, lemon juice is 2.5, strong acid. Diet cherry Coke is 3.0, it's a weak acid. Distilled water is 7.0, it's neutral. Toothpaste is 8.5, it's a weak alkaline. And ammonia, 12.5, is a strong alkaline. Understanding pH measurements and values will greatly assist your ability to keep the hair, skin, and scalp in the best condition possible. Reading labels correctly, selecting the right products for clients, and recommending products for home hair care will also be based on a good understanding of the pH values. Chemistry of cosmetics. And I know you ladies had a question about that on your homework sheet. So let's go over this. The Federal Food, Drug, and Cosmetic Act of 1938 defines cosmetics as articles intended to be rubbed, poured, sprinkled, or otherwise applied to the human body or any part thereof for cleansing, beautifying, promoting attractiveness, or altering the appearance. As a professional cosmetologist, it is important to understand the physical and chemical characteristics of cosmetics in order to better serve your clients. So, cosmetic classifications. The 6 general classifications are assigned to characterize cosmetics used in the cosmetology industry. There are 6 classifications. Knowledge of these cosmetic classifications will help you understand product labels and direct use. These classifications are based on how well the substance combines with another, as well as the physical characteristics of each. The 6 classifications are: 1, solutions; 2, suspensions; 3, emulsions; 4, ointments; 5, soaps; and 6, powders. So now they're going to explain each one of them.
Miss Michelle, I'm gonna log
Yes,
in.
ma'am.
I'm gonna log into Zoom on my phone because I have to Zoom while I'm Zooming. So you're gonna see
Okay.
another thing.
Huh? To
Yeah, yeah.
admit you? To admit, okay.
Yeah.
No problem.
All right, thank you.
You're welcome. Oh, I see it. Yeah. Got it? Okay. All right, so solutions. Now I'm breaking down the 6 cosmetic classifications. And the first one is solutions. Solutions are mixtures of two or more kinds of molecules evenly dispersed. For example, a solution is made by mixing a package of instant soup and a cup of hot water. Let me give that example again. A solution is made by mixing a package of instant soup and a cup of hot water. The dry soup would be called the solute, which in any substance that dissolves into a liquid and forms a solution. The water would be called a solvent, which is any substance that is able to dissolve another substance. The soup will be called the solution. Solutions do not separate when left standing and are generally clear mixtures. Stirring is usually required when dissolving a solute. Solutes can be either solid, liquid, or gas. Hydrogen peroxide would be an example of gas mixed with a liquid to form a solution. There are three classes of solution. One is dilute solution, contains a small quantity of the solute in comparison to the quantity of solvent. Two, concentrated solution, contains a large quantity of the solute in comparison to the quantity of solvent. And three, a saturated solution cannot take or dissolve more of the solute than it already holds at a given temperature. Water is considered a universal solvent because it is capable of dissolving more substances than any other solvent. Only oil and wax cannot be dissolved in water. Only oil and wax cannot be dissolved in water. Okay, so number 2 on your cosmetic classifications is suspensions. Suspensions are also mixtures of 2 or more kinds of molecules. Unlike solutions, however, suspensions have a tendency to separate when left standing and therefore need to be shaken before using. So, perfect example they always go to is the vinegar and oil as salad dressing preparation. If left standing, the mixture of vinegar and oil separates and needs shaking before being used. Many lotions used in the cosmetology industry are suspensions. Calamine lotion is another example. And if anybody ever had an insect bite and had to put that pink stuff on you, you know you always had to shake that back and forth before you put it on the cotton, when you pour it on the cotton. Emulsions, emulsions. Emulsions are formed when 2 or more non-mixable substances, like oil and water, are united with the help of a binder or gum-like substance. The gum-like substance might be a soap. Generally, classifications of emulsions are oil and water, perm solutions, and water in oil, cold creams. Most emulsions used in the cosmetology industry are classified as oil in water. Okay, once again, most emulsions used in the cosmetology industry are classified as oil in water. Ointments. Ointments are a mixture of organic substances and a medicinal agent, usually found in a semi-solid form. Water is generally not present in this mixture. Ointments type preparations come in the form of sticks like lipstick, pastes like some eyeshadows or blush. Okay. And mucilages, mucilages, are thick liquids such as styling lotions. Okay, this is under ointments. We still talk about the cosmetic classifications. And I was on number 4, ointments. 5 is soaps. Soaps are mixtures of fats and oils converted to fatty acids by heat and then purified. Soaps used in the cosmetology industry generally fall in the categories of deodorant soaps, beauty soaps, medicated soaps, and liquid soaps. Powders. Powders are equal mixtures of organic and inorganic substances that do not dissolve in water and that have been sifted and mixed until free of coarse, gritty particles. Perfume and shades of colors are usually added for purposes of enhancement. And then shampoos. Now, how important is shampoos? You are now ready to take a look at the chemistry of products and procedures for services in the salon. The natural place to start is with the service most often performed, which is shampooing. You shampoo primarily to clean the hair and scalp and to remove all foreign matter, including dirt, sebum, which is natural scalp oil, cosmetics, hairspray, skin debris, without adversely affecting either the scalp or the hair. So what they're saying is by removing all of these products and sebum out of your hair, you want to make sure that you're not damaging the scalp or the hair by using anything that's what? Too high on that pH scale. Keep that in mind. Shampooing the hair is an important function as it is often the first impression the client has of the salon and of the stylist. Shampooing as part of the salon service can be a highly therapeutic experience when done in a caring, organized, and confident manner. Remember, the shampoo should be a smoothing, relaxing experience, and it sets the climate for all future services. Now, you might meet stylists that can cut their behinds off, okay? Can style. If they don't know how to talk to a client and don't know how to give a good shampoo, you won't have repeat business. I'm gonna tell you, I had people that come to me because of the shampoo and the massages. They want to feel them hands in there. Just think about it. Just like you go to a masseuse, they come to you to get the scalp manipulations and on your hands. I just got a manicure the other day, and I'm not going off subject. And it's one thing like a doctor working on a doctor. So she's working on me, and I'm a cosmetology instructor. She did not do any of the massages on my hands. She put a little oil on and went back and forth. And I was in a hurry, so I didn't want to get into the technical effleurage, petrissage. I didn't want to get into all of that, but she know better. I think people get comfortable and they just forgot all their schooling and the techniques. They just let it go out the window. And that's not everybody. That's most bodies once they get their license. So I hope you ladies give it your all. You'll be surprised how many your tips will come better, the repeat business, just by a simple scalp massage. Hair should be shampooed as often as necessary, depending on how quickly the scalp and hair becomes soiled. Frequency varies from individual to individual, and I'm so glad that they brought that up, because now the debate is, should I wash my hair every day or should I wash it every 2 days? Or should I wash it once a week or every 2? It's an individual preference. Okay, if you tend to oil up, then you need to wash it more frequently than somebody whose hair is a little drier and don't need to dry it out by washing it every 2 days. So that's why the book says it varies from individual to individual. Improper or irregular cleansing allows a breeding place for disease-causing bacteria and can lead to scalp disorders and even hair loss. Generally, oily hair needs to be shampooed more often than normal or dry hair. Strong alkaline shampoos are not recommended as they may make the hair dry and brittle. So if you have a client that needs the hair shampooed more often, you're not going to use something that's strong and alkaline. You're going to use something that's definitely like in the 5 or 4 or 3 range. Okay. So real quick, hair shampoo, how shampoo works. Even though the hair fiber beyond the scalp is dead, okay, a mixture of secretions from the sebaceous glands and perspiration from the sweat glands help maintain the hair and scalp at its natural pH of 4.5 to 5.5, allowing a shiny, alive appearance. Okay, we talked about that already. And briefly, we talked about the types of shampoo, so I'm just going to go through them. All-purpose, acid balance, plain shampoo, soapless shampoo, medicated, clarifying shampoo, anti-dandruff shampoo, liquid dry shampoo, powder dry shampoo, conditioning shampoos, color shampoos, and shampoos for thinning hair. This wide variety of shampoos has one desired result: a satisfied customer with healthy hair. It is essential for you as a cosmetologist to realize that not only shampoos that claim pH balance are necessarily acid balance, okay? An acid balance shampoo has a natural 4.5 to 5.5, okay? Rinses and conditioners. Shiny hair, healthy hair. Hair in optimum condition is rarely seen in today's salons. Hair's chemical composition is changed with perm and color services. Now, mind you, this is so true. Shiny hair, healthy hair in optimum condition is rarely seen in today's salon. So when most people come in that door, they coming in for professional help. There's no picture perfect hair when they walk in that door. That's why they coming to see you as a professional. They need help, whether it's as small as getting a good shampoo and conditioning treatment, or a hair cut, or a color, or a perm. But they still need you to give them that professional service. Hair chemical composition is changed with perm and color services. Bonds are broken that can never be rejoined. Hair becomes chemically and mechanically damaged through daily care. The tools of your profession, thermal styling tools, blow dryers, teasing combs, brushes, and even rollers can cause a degree of damage. Other factors that can affect hair condition are the environment and products such as alkaline shampoos. And what do they mean by environment? If you live in a hot climate where it's every day is 80 degrees or higher, and you have the humidity, or you can live in Alaska in a cold climate, and it can ruin your skin or nails. Everybody's an individual. So this is what they mean about environment. Once the natural bonds in the hair are broken, nothing can be done to actually reconnect them and repair the hair. As a stylist, it is your responsibility to be aware of products that can strengthen hair, add body, and protect it from further damage. Scientists have formulated products that can smooth rough hair cuticles, add protein molecules to the hair shaft, and humectrants, which is another word for moisturizers, to replace moisture to dry hair. It is important for you to investigate these products. I'm gonna read that again. It is important for you as a stylist, cosmetologist, to investigate these products to help your client's hair to be as cosmetically pleasing as possible and to prepare their hair properly for chemical services. To achieve this, it is important for you to know why and when each product type is used, and the excuse me, and the results you can expect to achieve. So, what is cosmetic appearance? Is the luster or shine of the hair. If the layers of the outer cuticles stand away from the hair shaft, the hair will appear rough and dull. Porosity refers to the ability of the hair to absorb moisture, liquids, or chemicals. Manageability is determined by how easily a comb can pass through wet or dry hair. And elasticity is the ability of the hair to stretch and return to its natural shape without breaking. Healthy hair can be stretched about 50% when wet and up to 20% when dry. Tensile strength measures the amount of tension that can be applied before the hair breaks. And this is why when you do most of your sculptures, you have your spray bottle, you spray in the hair wet. So when you do your sculptures, you can put tension on it, and then the elasticity will give it that 50% stretch versus dry hair. Okay. Right. Rinses. Rinses affect mostly the surface of the hair. They're not going to penetrate into the hair shaft. They're going to coat it. Rinses are usually applied to the hair and rinsed off immediately. They sometimes leave a coating that surrounds each hair strand. Some rinses can actively be detrimental to the hair because they contain ingredients that build up on the hair surface. This buildup can make the hair feel limp, attract dirt, and make it difficult to control. Rinses are applied to the hair to help close the cuticle and make the hair feel soft and manageable. There are several effective rinses on the market today. Many rinses and conditioners are formulated for specific types of hair by chemists who specialize in the study of hair. At one time, however, all rinses had to be prepared in the salon or by the consumer at home. Rinses you should be familiar with include 1, vinegar and lemon. They are acid rinses. They help keep the cuticle compact. The vinegar rinse is mixed by using 2 tablespoons of white vinegar with a pint of tempered water. A lemon rinse uses the strained juice of 2 lemons or 15 drops of concentrated lemon extract, the kind of lemon extract you can just get in a bottle, ready to go. Adjust with water to a pH 4.5 to 5.5. Acid rinses usually have a very low pH, 2 to 3 on the scale, and are designed to dissolve soap scum and curds, untangle and separate the hair, and add sheen. Soap scum caused by the combination of the minerals in the water and the fatty acids of soaps is the residue remaining on the surface of the hair after shampooing. An acid rinse can also be used to counteract the alkalinity present after a chemical service. 2 is cream rinses. Soften and add luster, making tangled hair easier to comb. A cream rinse is creamy in appearance and adheres to the hair shaft. It adheres to the hair shaft, even after ordinary rinsing, thus leaving the hair with a soft feel and much easier to comb and handle. Cream rinses are only slightly acidic and do not have the same function as acid rinses. In selecting a cream rinse, be sure to select one with a proper pH level for your needs. And number 3 is medicated rinses. They are designed with ingredients that control minor dandruff and scalp condition. Minor dandruff and scalp conditions. They can usually be applied with cotton, or poured over the scalp, followed by a 1-minute scalp massage. But be sure to follow manufacturer instructions. There are active ingredients such as benzoyl chloride and lauryl isoquinoline bromide and polysorbate leave the hair luxurious and manageable. Now we move into conditioners. Conditioning is an important step in your client's hair needs. Sometimes a client's hair may be in great condition and only require a rinse to smooth the cuticle. But in many cases, the hair has been dried out and damaged by strong alkaline shampoos, chemical damage, or heat styling. Any amount of heat can damage the cuticle layer over time, leaving a rough, dry feeling. In these cases, a conditioning treatment may be needed. Conditioners usually penetrate deep into the hair so they can, I'm sorry, my cat just jumped off the roof. She just got 9 lives. Oh my goodness. Conditioners usually penetrate deep into the hair, so they are formulated directly from rinses. In order to achieve maximum penetration, they are usually kept on the hair for a specific length of time. Okay, so in other words, if you're doing a deep conditioner, they usually stay on the hair for 25-30 minutes with a plastic processing cap underneath the dryer. Because sometimes you could give a deep conditioner treatment to a client and they running cold. Some people body temperature run cold, some people run hot. So if that's the case, you need to give them some artificial heat, which is usually your heated dryers. Okay, so the length of time a conditioner should be left on the hair depends on the formulation and purpose. Sometimes the addition of heat is recommended to open a cuticle, which allows for better penetration. Read the manufacturer's instructions before applying. Always read it because every company is different. Remember, hair damaged, and they put in parentheses, damaged, generally refers to bonds, the sulfide, etc., that have been broken through the application of chemical services or thermal styling. Conditioners don't actually repair broken bonds, but rather fortify the damaged areas of the hair and protect it against further damage. For chemical services or heat, okay, they protect it against further damage from chemical services or heat. They may also alter the way hair behaves, giving it less stretch or reducing the relaxation of a set. Conditioners provide a temporary remedy for existing hair problems. Okay, so I'm just going to name some of these conditioners. You have an instant conditioner that coats the hair shaft and restores moisture and oils. You have number 2, a normalizing conditioner, also usually contain a vegetable protein and have an acidic pH, which causes the cuticle to close after alkaline chemical services. That's the normalizing conditioner. 3, the bodybuilding conditioners are required when hair is fine and limp and contains too much moisture to maintain a good style. And 4 is moisturizing conditioners. Contain hydrolyzed animal proteins and are recommended for dry, brittle hair that has been mechanically or chemically damaged. And 5, you have your customized conditioners are formulated to meet special needs. These are the ones that I like. I like mixing my own conditioners together, customize them. When a client's hair requires a combination of moisture and bodybuilding properties, you may customize the treatment, mixing a moisturizing conditioner with a bodybuilding protein product to improve the condition of your client's hair. Does anybody have any questions about the homework assignments? Okay, any questions? This is a pre-test. Next week, you're going to get your test. Everybody's going to get chapter 5 test. Any concerns? No? Okay. Let me. We got how many minutes? Haha, here we go. We left off with some questions yesterday. Let's see. A shampoo that contains orvis root powder to absorb soil and oil is classified as what, ladies? Color shampoo, powder dry shampoo, anti-dandruff shampoo, or liquid dry? It really helps if even if you guess. This is a learning experience, okay? Nobody wants to guess? It's a powder dry shampoo. The orvis root powder shampoo helps absorbs the soil and oil is classified as a powder dry shampoo. The ability of the hair to stretch and then return to its natural shape without breaking is what?
Elasticity.
Elasticity, very good. Acid rinses help what? Do they open the cuticle, close the cuticle, add softness, or control dandruff? Acid rinses.
Close the cuticle.
Close the cuticle.
Very good. Close the cuticle. Very good. What type of conditioners contain hydrolyzed animal proteins and are recommended for dry, brittle hair that has been mechanically or chemically damaged? Is it moisturizing conditioner, normalizing conditioner, customized, or bodybuilding conditioner?
Moisturizing.
Very good. Moisturizing conditioner. What type of conditioners coat the hair shaft and restore moisture and oils, but do not penetrate into the cortex or replace keratin in the shaft? Is it instant, moisturizing, bodybuilding, or normalizing?
Instant.
Very good, instant. I've been paying attention, very good. Using a protein conditioner would help achieve all of the following all except, okay, which one? Is it fortifying damaged areas? Is it alter the way the hair behaves? Is it increase new hair growth? Or is it to protect against further damage? Using a protein conditioner would help achieve all of the following except. It's increased new hair growth because the hair grows from inside out. So anything that you put on the hair is not going to make the hair grow. What it's going to do is keep your hair that's already growing outside your head healthy, shiny, manageable, okay? Not to the point where it's not going to break as much. So when your new growth comes in from the inside out, it's going to enhance that, okay? It's going to make your hair be able to grow healthy and shiny without breaking, okay? So the answer is increases new hair growth, but that's the only one that does not fit. Fortifying damaged areas, that's what protein conditioner will do. Alter the way the hair behaves, it will do that. Protect against further damage, it will do that, but it will not increase your new hair growth, okay? The purpose of a waving lotion is to what? Is it to break the disulfide bonds? Is it to restore the salt bonds? Is it break salt bonds or is it restore the disulfide bonds? Purpose of a waving lotion is to break the disulfide bond. Remember, the chemicals are going to break that disulfide bond, okay? The purpose of a neutralizer is to what? Is it to break the disulfide bond, to break the salt bonds, restore the salt bonds, or restore the disulfide bond?
Restore the disulfide bonds.
Exactly, because the waving lotion is breaking it, and your neutralizer is going to restore it back. Absolutely correct. Okay, so I would recommend that you go back over your notes. Okay, yes, last week we did, we got into chapter 5. This week, just reviewed it. And next week you'll be getting your test right before your spring break. Isn't that wonderful? It's a wonderful consolation prize. I want to thank you ladies for joining in on the Zoom. I appreciate your questions and your answers and your participation. I really do. And I hope you ladies have a wonderful weekend, okay?
You
Any more
too.
questions? All right, thank you so much. I'll see you next week.
See you next
Bye.
week.
Bye. Bye.